Hello, everyone. Welcome to today's presentation. I'm excited to have you here. Today, we will be exploring the fascinating topic of understanding quadrilaterals. This is the first slide, the cover slide, so I just want to briefly introduce what we'll be covering. We'll look at the different types of quadrilaterals, their properties, and how to identify them. So, let's get started and dive into this interesting subject together. Let's take a look at the table of contents for today's presentation. First, we'll start with curves, which are a fundamental part of geometry. Then, we'll explore the classification of polygons, which helps us understand different shapes and their properties. Moving on, we'll cover quadrilaterals, a specific group of four-sided figures, and look into their properties and types. Next, we'll examine the parts of a polygon, which are essential to understanding their structure. We'll also discuss diagonals of a polygon, which connect non-adjacent vertices and play a key role in analyzing shapes. Then, we'll delve into the sum of interior angles of polygons, a crucial concept for calculating angles in various polygons. Following that, we'll focus on specific types of quadrilaterals, such as rhombus, square, rectangle, parallelogram, and trapezium, highlighting their unique properties. We'll also look into the classification of these quadrilaterals based on their sides and angles, like whether they are regular or irregular. Throughout this presentation, our goal is to build a clear understanding of these geometric figures, their parts, properties, and how they relate to each other within the broader context of geometry. Today, let's talk about curves, specifically plane curves. A plane curve is essentially a curve that lies flat within a single plane, like a sheet of paper. Think of it as a line or a shape drawn on a surface. Something you could trace with a pencil. These curves can be either closed, meaning they form a complete loop, or open, which means they start and end at different points. Understanding these basic properties helps us see how curves behave within a plane, which is fundamental as we explore more complex geometric concepts later on. Let's talk about polygons. A polygon is essentially a closed figure on a plane, which means it has a boundary that forms a complete loop. To qualify as a polygon, it must have at least 3 straight sides. These sides are straight lines that meet at points called vertices. It's important that each vertex connects exactly 2 sides, and importantly, the sides only intersect at these vertices. They don't cross each other anywhere else. This helps keep the shape simple and well-defined. Understanding polygons is fundamental because they form the building blocks for many geometric concepts we'll explore. They also appear everywhere around us, from building designs to nature, making this a key idea in understanding shapes and space. Let's talk about the parts of a polygon, starting with its vertices. The endpoints of the sides are called vertices, and when we name a polygon, we do so by naming its vertices in a specific order, either clockwise or counterclockwise. This helps us clearly identify each corner of the shape. Now, moving on to sides. Consecutive sides are simply sides that share a common endpoint. For example, in the 4-sided polygon shown here, we could label the vertices as ABCD, BCDA, or ADCB. The key point is, it doesn't matter which letter you start with, as long as you continue naming the vertices in order, either clockwise or counterclockwise. Let's look at an example. Sides AB and BC are consecutive because they share vertex B similarly. Sides BC and CD are consecutive, and so on. In this particular polygon, there are 4 pairs of consecutive sides, highlighting how the sides connect around the shape. Understanding these parts is fundamental because it helps us analyze the properties of polygons and their relationships. Recognizing vertices and consecutive sides allows us to better understand the shape structure and how it fits into the larger study of geometry. Now, let's talk about diagonals of a polygon. A diagonal is any segment that connects 2 vertices of the polygon, but importantly, these vertices cannot be next to each other. So, if you imagine a 5-sided polygon like the one shown here, the diagonals are the segments that link non-adjacent vertices. In this example, segments QS, SU, RT, and QT are all diagonals. Understanding how to identify these diagonals is crucial because they help us analyze the shape, structure, and properties. There's also a handy formula to find the number of diagonals in any polygon. This formula considers the total number of vertices and simplifies the process, especially for polygons with many sides. So, recognizing diagonals is not just about drawing lines. It's about understanding the internal connections within a polygon, which plays a significant role in many geometric applications and proofs. Now, let's talk about the classification of polygons. Polygons generally fall into two broad categories: convex and not convex, which is sometimes called concave. The key difference between these two lies in their shape and how their angles and sides relate. A polygon is considered concave if you can find 2 points somewhere inside it, and when you draw a straight line segment between those points, that segment cuts through at least 2 sides of the polygon. Think of it like a cave or a dent in the shape. There's an indentation that makes it non-convex. On the other hand, if a polygon doesn't have any such indentations, that is, if you can draw a line segment between any 2 points inside it without cutting through the shape, then it's called convex. Understanding whether a polygon is convex or concave helps us analyze its properties and how it behaves in different applications, which ties into the overall theme of geometric classification and understanding shapes. Now, let's explore the different types of polygons based on the number of sides they have. As we've seen, polygons are classified by their sides, angles, or vertices. For example, a triangle is a 3-sided polygon, so it has 3 sides and 3 angles. Moving on, a pentagon has 5 sides, which is pretty straightforward. When we talk about a septagon or heptagon, we're referring to a 7-sided polygon. Both terms are used interchangeably. A nonagon, on the other hand, has 9 sides, which makes it a bit more complex. Then we have the quadrilateral, which is a 4-sided polygon. Think of squares and rectangles. Next is the hexagon with 6 sides. These are common in nature, like honeycombs. An octagon has 8 sides, and you might recognize this shape from stop signs. Lastly, a decagon has 10 sides. Understanding these different types helps us see how polygons can vary widely in shape and complexity, but they all share the fundamental property of being closed figures with straight sides. This classification by sides is a key concept that connects to the overall theme of understanding geometric shapes and their properties. Let's talk about regular polygons. When we say a polygon is both equilateral and equiangular, we're describing a shape where all sides are the same length and all angles are equal. Such a polygon is called a regular polygon. It's a beautiful, symmetrical shape that often appears in design and nature. An important point to remember is that for a polygon to be considered regular, it also has to be convex. That means all its interior angles are less than 180 degrees, and the shape doesn't cave in on itself. Connecting this to our overall theme, regular polygons showcase perfect symmetry, which is fundamental in understanding geometric principles and their applications. They serve as building blocks for more complex shapes and structures, making their study both interesting and practically important. Let's now look at how to find the sum of the interior angles of a polygon. The key formula to remember is that the sum equals n2 times 180 degrees, where n is the number of sides. This means that if you know how many sides a polygon has, you can easily calculate the total of all its interior angles. It's also important to note that the sum of the exterior angles of any polygon is always 360 degrees, regardless of the number of sides. That's a consistent fact across all polygons. However, keep in mind that the sum of the interior angles can vary. It can be more or less than 360 degrees, depending on the shape. The formula we just discussed gives us a way to find that sum precisely, which is really useful when analyzing different polygons. So, understanding this relationship helps us connect the shape's structure to its angle measures, tying into the broader theme of understanding geometric properties. Today, we're diving into quadrilaterals. A quadrilateral is simply any shape that has 4 sides. The name itself comes from Latin roots, quadri meaning 4, and lateral meaning side, so it literally describes a shape with 4 sides. Now let's look at some key properties that define quadrilaterals. First, they all have four sides, which is the most obvious feature. Second, they also have four vertices, meaning four corners where the sides meet. Third, they always have four angles, one at each vertex, making the shape geometrically balanced. And finally, they have at least one pair of diagonals, lines drawn between opposite vertices, that can help us analyze their properties further. Understanding these properties helps us see how quadrilaterals fit into the bigger picture of geometric shapes. Whether we're working with squares, rectangles, or trapezoids, these core features remain consistent. So, recognizing these properties is essential for identifying and working with any quadrilateral in geometry. Let's talk about some important properties of quadrilaterals. First, the interior angle sum property. This states that if you add up all the interior angles of any quadrilateral, the total will always be 360 degrees. This is a key concept because it helps us understand the fundamental angle relationships within these four-sided shapes. Next, we have the exterior angle sum property. Similarly, this tells us that the sum of the exterior angles of any quadrilateral is also 360 degrees. This is true no matter what type of quadrilateral we're dealing with. Both of these properties are crucial because they connect the angles inside and outside the shape, reinforcing the idea that quadrilaterals have consistent geometric properties. These principles also help us solve many problems involving angles and shapes in our broader study of geometry. Now, let's take a closer look at the different types of quadrilaterals listed here, starting with the trapezium, which is a quadrilateral with at least one pair of parallel sides. Moving on to the parallelogram, where both pairs of opposite sides are parallel, making it a very special type of quadrilateral. Next, we have the kite, characterized by two pairs of adjacent sides that are equal in length, creating a distinctive shape. Then there's the trapezoid, which in some regions is used interchangeably with trapezium, but generally, it refers to a quadrilateral with only one pair of parallel sides. The rectangle follows, which is a type of parallelogram with four right angles, making it very symmetrical. The rhombus is similar to the square but without the right angles. All sides are equal, and opposite angles are equal as well. We also see the isosceles trapezoid, which is a trapezoid with non-parallel sides that are equal in length, giving it a very balanced appearance. And finally, the square, which combines all the properties we've discussed: equal sides, right angles, and symmetry. Understanding these different types helps us see the diversity within quadrilaterals, which ties into the overall theme of geometric classification and how these shapes can be used in various real-world applications. Let's take a closer look at the rectangle. A rectangle is a four-sided shape, and one of its most important features is that every angle is a right angle, which means each one measures 90 degrees. This is a key characteristic that sets it apart from other quadrilaterals. Now, another important point is that opposite sides of a rectangle are both parallel and congruent. Parallel sides never meet, and congruent sides are equal in length, which helps us understand the symmetry and balance in this shape. Additionally, the diagonals of a rectangle have some interesting properties. They bisect each other, meaning they cut each other exactly in half at the point where they cross. Plus, the diagonals are congruent, so they are equal in length. All of these properties, right angles, parallel and congruent opposite sides, and congruent diagonals, work together to give the rectangle its distinctive shape. Connecting this to our overall theme, understanding these properties helps us recognize and distinguish rectangles in various contexts, whether in design, architecture, or geometry. So let's talk about the rhombus. A rhombus is a special four-sided shape where all four sides are exactly the same length. That means if you measure any side, it will be equal to the others. Now, an important property is that opposite sides are parallel, which makes it a type of parallelogram. This parallelism creates interesting angles and symmetry within the shape. Another key point is about the angles. Opposite angles are equal, which helps us identify and work with rhombuses easily. Now, here's something really fascinating about the diagonals, those dashed lines in the second figure. They bisect each other, meaning they cut each other exactly in half, and they do so at right angles, which means they cross at 90 degrees. This perpendicular intersection of diagonals is a defining feature of a rhombus and plays a crucial role in its properties and how we analyze it. Connecting this to our overall theme, understanding the properties of a rhombus helps us see how symmetry and specific angle relationships come together in geometry to form these unique shapes. It's a perfect example of how simple rules, like equal sides and perpendicular diagonals, combine to create complex and elegant figures. A square means a right angle, which is 90 degrees, and it also shows equal sides. So a square has both these key features. All four sides are the same length, and every corner is a perfect right angle. You can think of a square as a special kind of other quadrilateral. For example, it's like a rectangle but with adjacent sides equal, or like a parallelogram but with all angles at 90 degrees, or like a rhombus but with all angles at 90 degrees. These connections help us see how a square fits into the bigger picture of shapes and their properties. Understanding these similarities and differences really ties into our overall theme of exploring geometric figures and their unique characteristics. Let's take a closer look at the parallelogram. A parallelogram is a quadrilateral where opposite sides are parallel, which is a key defining feature. This parallelism leads to some interesting properties, such as the fact that opposite angles are equal, so the angles labeled A are the same as the angles labeled B. Additionally, the opposite sides are equal in length, which adds to its symmetry. Another important point is that the adjacent angles are supplementary, meaning they add up to 180 degrees. The diagonals of a parallelogram bisect each other, dividing each diagonal into two equal parts, but it's worth noting that the diagonals themselves are not necessarily equal in length. Now, the parallelogram serves as a sort of parent shape for several other quadrilaterals. For example, a rectangle is a special type of parallelogram where all four interior angles are fixed at 90 degrees. Similarly, a rhombus is a parallelogram with all sides equal in length. And finally, a square combines both features. It's a parallelogram with all sides equal and all angles at 90 degrees. Understanding these relationships helps us see how more specific shapes are built upon the basic properties of the parallelogram, tying into the bigger picture of how quadrilaterals relate to each other. Let's take a closer look at what a trapezium is. Essentially, a trapezium is a quadrilateral, meaning it has four sides, and it has at least one pair of sides that are parallel. This is a key defining feature. Now, when we talk about an isosceles trapezium, things get a bit more specific. In this case, the non-parallel sides are equal in length, and the angles that come from a parallel side are also equal. This symmetry gives the isosceles trapezium a very balanced and harmonious appearance. It's important to note that the terminology varies depending on where you are. In the UK, we call it a trapezium, but in the US, you'll hear it referred to as a trapezoid. Understanding these distinctions helps us see how the properties of these shapes relate to their symmetry and overall structure, which ties into our broader theme of exploring geometric figures and their unique characteristics. A kite is a special kind of quadrilateral, and what's unique about it is that its four sides can be grouped into two pairs of equal length sides, and these pairs are adjacent to each other. Think of how a traditional flying kite-shaped figure looks. It's no coincidence that the name comes from that image. Now, one of the key features of a kite is that two pairs of these adjacent sides are equal in length. This symmetry is what gives the shape its distinctive appearance. Another important point is about the diagonals. In a kite, one diagonal actually bisects the other, meaning it cuts it exactly in half. This creates a kind of internal symmetry that's quite distinctive. Also, the angles come into play here. The angles that are opposite each other and lie between the sides of unequal length are equal. This helps us identify and confirm a shape as a kite when analyzing its angles. Lastly, the diagonals intersect at right angles. That is, they cross each other at 90 degrees. This perpendicular intersection is a defining characteristic of the kite shape. Understanding these features helps us recognize a kite and see how it fits into the broader family of quadrilaterals. connecting the geometric properties to real-world shapes like flying kites. Now, as we wrap up our discussion on quadrilaterals, I want to emphasize how understanding these shapes is fundamental to geometry. We've seen that quadrilaterals are four-sided figures, and their properties vary widely. Think of squares, rectangles, rhombuses, and trapezoids. Each has unique features, but they all share the common trait of having four sides. Recognizing their properties helps us solve problems more efficiently and see how shapes relate to each other. Remember, the key to mastering quadrilaterals is understanding their angles, sides, and symmetry. This knowledge not only deepens our geometric understanding, but also connects to real-world applications, from architecture to design. So, keep exploring these shapes, because they truly form the building blocks of more complex geometry concepts.